Okay, Lakshay, let's go ahead with your mock for the IOCL. So please proceed and first of all, introduce yourself briefly to us.
Good evening to one and all present here. As you already know, my name is Lakshay Khitta. I am 22 years of age. I belong to a place famously known as Queen of Hills, Shimla. I have done my matriculation and higher secondary from Sainik School, Suhanpur Tira. Both my mother and my father are in noble profession of teaching. Presently, I have completed my B.Tech in mechanical engineering from NITIE Hamirpur. During my B.Tech, the project which I have worked on was how to make a cost-effective ventilator design. And in college time, the IC engine, basic thermodynamics, and hydraulic machines were among my favorite subjects. Apart from studies, I have attended many camps like NCC camps, water sports camps, and mountaineering camps. And about my hobbies, I'm a sports enthusiast. I love to play football and snooker. I like to push my limits through trekking and hiking from time to time. And in my meantime, I also like to listen to spiritual gurus and practice meditation. That was brief introduction about me.
What kind of meditation do you practice?
So nowadays I am the meditation given by Osho Rajneesh, the dynamic meditation. I am practicing that nowadays. Otherwise, there are many forms of meditation. Some of them I have tried, like Kundalini meditation, and to focus on a thing like in the spot between our eyes or any like diya and all in Mombatti vagara.
Okay, so Lakshay, why you want to join? What are you doing presently?
So presently, I have passed out from the college and I'm preparing for the examination and PSUs, etc.
So why you are interested in IUCL?
So I have been a very curious kid from early childhood only. So I like to learn very different things, and I think, sir, the diversified nature of IOCL will be quenching my thirst for knowledge. And the second reason is that IOCL has been doing consistently very good and being on the top. So I think, sir, a company is on the top because of the workers that are working in it. And sir, I think it will be a very बहुत सर खुशी की बात होगी कि मुझे वहां के लोगों से सीखने को मिलेगा. And the third reason is the work life balance. I have asked my teachers, my mentors, and my seniors, and they all have suggested that IOCL have the best work life balance. And I think, sir, in that environment I'll be growing and I'll be an asset to the company.
Okay, so let us say, have you received calls from other organizations also?
Sir, not till now, sir, no.
So let us say if you got the opportunity in some other organization, let us say ONGC or BHEL maybe. So then what will you do?
So all PSUs are very good, sir. There can be no comparison between them. But the thing that I have told you earlier, that the thing is that I'm curious and I like to learn different things. And I think, sir, IOCL is best in this and have very diversified nature. So I like to prefer IOCL. And sir, all the PSUs are best, and there can be no comparison. But that gives edge to IOCL, that it's diversified and that thing.
Okay, and you mentioned about the project that you have done, right? Have you done any kind of internship?
Sir, no, sir. And due to COVID, I have not done, but I have done project with other branch students on the traffic recognition system, sir.
Okay, and what was your final project?
So finally, a project was on how to make a cost-effective ventilator design.
What is it? Very briefly.
So for that, we have to firstly know about.
And basically what you did in that project. As you know, it was a group project, right?
Yes, sir. Particularly my work in the project was to calculate the forces, torque, and the volume that will be supplied, the tidal volume. And from that, we have to choose what type of stepper motor and what type of machinery we have to use. So the calculation part, which was done in the project, was done by me, sir.
So what was the use of this project?
So basically what happens is, sir, there are two types of mechanical ventilation. One is resurrector bag, which is very cheap and has very low performance. And another is that are the ventilators which are being provided in the hospitals. They are very costly and they have high performance also. The main purpose was that to build a cheap but performance also be good, not the best, but it can be that much of level that it can help the patients. So what we have done in differently in this project was, firstly, we tried to reduce the cost, and there are two main things that we have reduced cost on. First off was the calculation of tidal volume. So actually there are two types of sensors in the ventilators. One is flow sensor and another is pressure sensors. So flow sensors is used to calculate the volume, but the volume is not that much integral part that that pressure is. So what we did, that we calculated the tidal volume by calculation only for the different speeds and different breath per minute and different inputs of IE ratio, that is inspiration to expiration time ratio. We have calculated all the possible values and we have stored that in the data set, and that will reduce the cost of the sensor, sir, that flow sensor. But
Hey, Lakshay, you told me your hobbies, football, right?
yes, sir.
Which team do you like the most?
Sir, in the club it is Barcelona, and sir, in country it is Argentina and India, of course.
So who are the famous players in India?
So in India, it's Sunil Chhetri. It's presently everyone knows about Sunil Chhetri, and also presently he is the famous. And also one fact we don't know about Sunil Chhetri is he's one of the top highest scoring person in the football. But we all know about Ronaldo and Messi, but he's also one of the top five if we include all the matches.
Okay. Can you draw the Mohr circle for the football?
Yes, sir. It will be, if we assume that to be a spherical and a spherical vessel, spherical pressure vessel. So should I draw it on paper, sir?
No, you just tell me if you can tell.
So in spherical vessel, sir, the all stresses will be equal, unlike the cylindrical. So it will be a point, sir.
So what does
In
that mean?
Point in the x-axis means, sir, no shear stresses will be there. Only the tensile stresses will be there, sir.
So can you tell me the plane of maximum? Okay, can you let me know what is going to be the value of the principal stress at 60-degree plane in this case?
Sir, at 60 degrees, sir, it will be same, sir. For all the planes, the value of principal stresses will be same, sir. That is the thing about.
Okay, so let us say if it fails.
Yes, sir.
So in which plane it is going to fail, and in which particular kind of stress it is going to fail?
It will be, sir, circumferential stress only, sir, means tensile stress only, and it will be failing in the plane that is parallel to the tensile plane, that is zero at the 0 degrees, sir.
Why at that 0 only?
Because, sir, there will be maximum stress at that only, sir.
So what is the value of stress then at 30 degree?
It will be same, sir, for all the.
Then how you can say that it is going to fail at?
No, yes, sir, sorry, sir. It can fail at any plane, sir, depending upon the irregularity, wherever the irregularity or that thing will be there, or cracking and all these things, imperfection, there it will fail, sir. Yes, sir.
Okay. So, okay, over to Vishal, sir. Vishal, sir, are you there?
Yes, sir. Yes, sir. Thank you. Okay, Lakshay. So, Lakshay, let me ask you some questions from the subject actually you mentioned, IC engine and basic thermodynamics as your favorite subject.
Yes, sir.
Lakshay, first, can you tell us the difference between the diesel and biodiesel?
So actually, diesel is the product which is refined from the crude oil, which we extract from the earth. But biodiesel, it is the diesel which are formed from the vegetable oils and the organic. By reacting the vegetables oil to the alcohol, we get biodiesel, sir. This is the difference. The extraction of diesel from that crude oil and biodiesel, we get chemical reaction of alcohols to the vegetable oils.
So can you tell us, Lakshya, any two advantage of using biodiesel and the problems with using this biodiesel as a fuel in diesel engine?
So I don't know much about that, but I think the biodiesel can be sticky and has this kind of, and will be
So that is advantage or disadvantage?
disadvantage, sir. It will be a disadvantage.
Why?
And because, sir, it will get accumulated inside the cylinder, sir, and it will stick in the injection system, sir. It can stick there, highly viscous.
Fine. Any advantage?
Advantage, it will be environmental friendly. That extraction and all these things will cause emissions also. So producing that will be less environment friendly. That much I only know, sir.
Fine. So you heard about cetane number, Lakshya?
Yes, sir.
Tell us in brief about cetane number, how we measure, and what is the use of actually defining this cetane number?
So cetane number is the number which is defined for the diesel, sir. Basically, the I don't know. I'm not remembering right now the compound which is having 100.
Forget about that. But just give me the use.
So use is that the more will be the cetane number, the less will be the anti-knocking properties of the fuel diesel, sir. एंड वी जो हम सर उसको निकालते हैं, एक्चुअली हम क्या करते हैं कि जो हमारे पास
एंटी नॉकिंग, हाई इज द cetane number, less is the anti knocking tendency. Is it right?
Yes, sir. No, higher will be the anti knocking, sir. Lesser will be the knocking tendency.
So if you are saying anti knocking, then you need to say lesser.
Yes, sir.
The knocking tendency.
Yes, sir. Right. Lesser will be the knocking tendency.
Actually, just tell me how we measure. Okay, you need not to mention the name of the, what you can say, those reference fuels. Just tell me how we measure cetane number. Like actually, can consider as A and B two reference fuel.
Yes, sir. Actually, let us assume that A is having 100 cetane number and B is having 0 cetane number. So actually, what we do is, sir, take the fuel which we have to measure the cetane number of, and then we will test and we'll see the knocking properties of that, and then we'll create a mixture of A and B and see the same knocking properties. We'll mix it such that the same knocking properties come from that we have got from the fuel, and in that mixture, the amount of A which is having 100 cetane number, the percentage of A will be determining the cetane number of the fuel.
Right. So what is the effect of this high cetane number? Like suppose if you are using a high cetane number fuel in diesel engine, you mentioned about knocking tendency, that knocking tendency is less.
Yes, sir.
But suppose if you will use diesel engine with supercharging, you heard about supercharging, turbocharging?
Yes, sir.
So if you are carrying out some kind of supercharging or turbocharging in diesel engine, what is the effect of that on knocking tendency?
So knocking tendency, sir. I think knocking tendency will reduce, sir, because in supercharging, the main purpose is that the pressure of the air which is incoming will be higher and density will be higher, and for that the temperature will automatically become higher, and the higher will be the temperature, the less knocking tendency will be there in the diesel engine, because we want higher temperature so that there will be no ignition delay while we are spraying the diesel in the compressed gas. So already if the temperature is higher, so lesser will be the knocking tendency.
Same will be the effect on petrol engine?
No, sir, it is opposite in the petrol engine, sir. The higher will be the temperature, the irregular flame front will be there, and higher will be the knocking, sir.
Lakshya, you heard about pulverization of coal.
Polymerization of coal, sir?
Pulverization of coal.
Pulverization, sir, I don't think so, sir.
Something related to thermal power plant. In thermal power plant, we carry out the pulverization of fuel. Coal. The fuel, generally we use coal only.
Sir, I don't know about that.
Fine. So, can you tell me the difference between specific heat and calorific value?
Specific heat, sir. Specific heat is the heat It is the heat we have to supply so that it can raise the temperature by 1 unit. But the other, what was the other thing, sir? You said calorific value.
Yes.
The calorific value, it is the heat which is generated by burning the unit fuel. So, sir, that much I know.
There are two type of that calorific value: high heating value, low heating value. You heard about that?
No,
High
no, sir.
calorific value, low calorific value.
High calorific. I'm not able to remember, sir, right now.
Fine. So let me ask you some questions from basic thermodynamics section. Okay, can you tell us something about second law of thermodynamics?
Sir, the second law of there are two statements in second law of thermodynamics, sir. One is a Kelvin-Planck statement and another is the Clausius statement. Basically, the Kelvin-Planck statement says that no engine can run only with one thermal reservoir. The meaning of that is, sir, the 100% of the heat cannot be transferred into the work. Some heat has to be wasted and go through the sink. So basically, it says that we cannot have 100% efficient heat engine. So this was Kelvin-Planck statement, and Clausius statement say that we cannot transfer heat from cold source to hot source without applying any work to it. That means we cannot have any refrigeration or heat pump which have infinite COP.
So let's just define three things, three very important things which are related to second law of thermodynamics only. What is irreversibility? What is available energy? Okay, and what is unavailable energy?
So firstly, you have said what is
available energy, irreversibility, and unavailable energy.
So available energy, it is the maximum energy which we can get from heat engine and that. And the available energy, it is like a maximum which we can have, the means it is not 100% efficient, but the efficiency which is maximum, like for the reversible engine, the maximum heat which we can maximum work which we can get, it is the available energy. And the unavailable energy, it is the energy which is destroyed, means it is always destroyed, sir. It is not like for the most efficient or reversible engine also there will be unavailable energy, but the irreversibility, it is the loss of available energy, sir. Loss of available energy is irreversibility.
Okay, let me ask you one more question from thermodynamics. What is Joule-Thomson effect? You heard about that? Joule-Thomson effect.
So what I think, sir, Joule-Thomson's effect is when we throttle any fluid. So the effect which have on fluid is Joule-Thomson effect. If the fluid is ideal gas or ideal fluid, then there will be no temperature change, or when we decrease the pressure, there will be no temperature change.
You are having a fluid for which the Joule-Thomson coefficient is negative.
Yes, sir.
Then what you will have?
Then, sir, we will negative. Then heating will be there, sir. Heating of fluid.
So yes. What do you think? That is in our hand, that Joule-Thomson coefficient, or is it something like the property of some fluid?
Sir, I don't exactly know, but it should be property, sir. Joule-Thomson coefficient.
Yes, it is a property. It's a property of fluid.
Yes,
so
sir.
You are having any idea about any gas which is having, because that is related to throttling of gases.
Yes, sir.
You need to mention, when we carry out throttling of gases, then we can
yes,
have more cooling. It's not related to liquid. So any gas which you can suggest for which this Joule-Thomson coefficient is negative? Normally, if you will carry out throttling at atmospheric temperature, atmospheric conditions, then actually we compare it with that only. Okay, Lakshya, my last question is to you. You heard about the BS6?
Yes, sir.
What is that?
Sir, it is the set of rules that are given by the government to prevent the emissions, means to save the environment, sir. These are the set of rules which are given by the government.
So
So
when was first those Bharat standards norms were started?
Sir, Bharat standard norms, I think in 1990s or 2000, sir. 1990 or between 1990 and 2000, sir. That time we have started that, and we have taken the Bharat stage from the Euro stages. So right now Bharat stage 6 is the latest one, and there are some properties and some things in that minimum amount of sulfur content, minimum amount of lead
Not
content,
minimum,
and
not minimum, maximum.
maximum, sorry, maximum,
Yes,
and
there's a maximum
minimum
permissible
octane number that a fuel should have. Yes, sir, maximum that and minimum.
Okay, Lakshay, let me give you the feedback.
Yes,
Lakshay,
sir.
overall, your delivery wise, your confidence wise, your performance is good. You know? Very nicely you introduced yourself, and I think technical questions also you tackled in the right direction. Let me discuss first with you what type of question actually I asked you. I started with the diesel and
Yes.
biodiesel. So you need to know something basic about the fuel classification, biodiesel, how it is different. Actually, we use biodiesel. Look, we don't use pure vegetable oil. Rather, we mix
Yes,
some kind of B20, B30, 20% vegetable oil, then 80% your the hydrocarbon oil, the diesel fuel. Why we use it in a blend? Because those fuels are having very good properties. Like the mixture, it is slightly more oily than your pure diesel. So wear tear is comparatively less. The pollution content is also less. Sulfur free for fuel easily you will have. You know,
yes,
sulfur is major source for some kind of pollution. So
yes, sir.
due to reducing all those kind of pollution effects and making the combustion much more efficient, we use a blend of actually biodiesel and this diesel hydro fuel. But there are lots of difficulties. One of the difficulty disadvantage actually you perfectly analyze, and you mentioned also that is more sticky because it forms some kind of oxidation takes place when it will react with oxygen. So it forms some kind of sticky substance. So आपको टैंक को बहुत अच्छे से इसको सील करके रखना पड़ता है. That is a problem, and also it is not that much volatile. अच्छा volatility property नहीं है. So there is a difficulty in making a good air fuel mixture. So other things also you can explore. But what I feel you need to know some basics about that. And biodiesel and all, how we measure. Blend also, how we actually produce that biodiesel. What are the different additives in petrol and diesel? So say additives pe kaam karna. Like, you know, we add some kind of additives to enhance the anti-knock tendency. So
Yes,
what
sir.
are additives for petrol and diesel that you can
Like ethanol and all these comes
yes,
under.
yes, alcohol also, yes, we add to mix. So calorific specific that you answered. High calorifically, low calorifically, you can explore. Let's say this time is very less, so I'm not going
Yes,
to
sir.
that area. What is high calorifically, low calorifically, you need to explore. Baki, second law you explain, availability, unavailable energy, all these things you explain. CTN number also. Although you forget the reference fuel.
Yes, sir.
Okay, but you answer. You know the process, how we actually explain the CTN number, how we measure this CTN number. Supercharging effect also you explained, right? Joule-Thomson coefficient, yes, it is related to that Joule-Thomson coefficient only, Joule-Thomson effect. Like when it is negative, we will get the heating effect. Otherwise, if it is positive, we will get the cooling effect. And yes, it is positive for most of the gases. It is a positive only.
Yes, positive.
If you will carry out their throttling at normal atmospheric temperature pressure. But yes, some of the gases like helium, hydrogen, you will have this negative.
Actually, helium, hydrogen, I was also thinking, but then I thought that these come under the ideal gases, so mu will be zero.
No. Ideal is not a gas actually. Let's say all gases are like air also, the carbon dioxide also. We treat all gases as an ideal gas.
Okay, sir.
So there is no gas which is known as ideal gas. Are you getting my point? Ideal is a theoretical word.
Hypothetical.
So when you say hydrogen gas, that is a real hydrogen gas, na, which you are filling in some kind of tank.
Yes, sir.
Are you getting my point? So, okay. Abhi, I think you are having very good chances. Lakshay, go with that type of energy confidence only, and you take some time. That is the only suggestion from my side. If you're not actually able to recall something, at least just pause for some time, 2-3 seconds you can take and try to recall, and then you can answer. Okay, Lakshay?
Okay, sir.
Anything you want to ask from my side?
No, sir. That's
okay.
Very helpful.
Good luck, Lakshay.
Thank you.
Okay.
Good night, sir.
ब्यूरो वगैरह वो देखने हैं आपको BS6 वगैरह although you answered BS6 वगैरह क्या होते हैं,
Yes,
but
sir.
how it is different from BS4, that also further you can explore, है ना? बाकी
Yes, sir. Okay.
मेरे ख्याल से IC इंजन में pulverization coal, you have not answered pulverization of coal.
That came under, sir, thermal power plant. So
Power plant,
I
yes,
didn't have.
yes,
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 sir.
yes. So
I
power
didn't
plant,
have.
they can ask some basic question from coal, classification of coal, okay, and pulverization, all these things, है ना? Okay, okay, Lakshya.
Okay, sir. Thank you.
Okay, so Lakshya, let me now give you the feedback, right?
Yes, sir.
हाँ, तो कुछ पोर्शन तो ठीक है, विशाल जी ने बताया आपका जैसे आपका डिलीवरी स्टाइल है, दैट इज ओके, कॉन्फिडेंस ठीक है, कोई ऐसा नहीं लग रहा। ओके, सो ओवरऑल तो ठीक है जो आपने आंसर किए, पर उसमें थोड़ी थोड़ी मैं फीडबैक दे देता हूँ आपको स्पेसिफिक।
Yes.
ओके, जैसे मैंने कहा आपको कि एक और चीज ध्यान रखना कि जहां पर जिस आप चाहते हो कि किसी डायरेक्शन में आप पर्टिकुलर इंटरव्यू को लेके जाना चाहते हो, तो एंड वहां पर करना। इफ यू आर नॉट मच ओके मेडिटेशन, जैसे आपने एंड किया मोस्टली हॉबीज और अपने मेडिटेशन एटसेट्रा के ऊपर किया,
Yes,
तो
sir.
रैंडम क्वेश्चन आपका हो सकता है वहां से पहला क्वेश्चन आपका आ जाए, तो यू शुड बी रेडी विद दैट। एग्जांपल, मेडिटेशन क्या होती है, डिफरेंट फॉर्म्स ऑफ मेडिटेशन क्या है, एंड ऑल दैट, व्हाई यू प्रैक्टिस दैट फॉर्म ओनली एंड ऑल दैट।
Yes, sir.
एंड दूसरी बात है, जैसे फिर मैंने पूछा आपसे कि IOCL क्यों ज्वाइन करना चाहते हो, तो आपने
Yes,
कहा
sir.
कि मैं मतलब क्यूरियस हूँ और अपना मतलब यूटिलाइज करना चाहता हूँ, ऑल दैट, डाइवर्सिफाइड है, वर्क लाइफ बैलेंस है। दो चीजें एक तो इंक्लूड करनी है, एक तो यू हैव टू टेल अबाउट द IOCL, जो आपने बताया कि डाइवर्सिफाइड है, डाइवर्सिफाइड जनरल टर्म है, या वर्क लाइफ बैलेंस अच्छा है, इवन द रिन्यूमरेशन इज आल्सो क्वाइट गुड, सो दैट इज व्हाट एन इंजीनियर कैन लुक फॉर,
Yes, sir.
राइट? इट्स काइंड ऑफ ए, सो एट द सेम टाइम आप ये बोलोगे कि व्हाटएवर द नॉलेज दैट आई हैव गेन्ड, आई विल बी एबल टू यूटिलाइज दैट। डाइवर्सिफाइड है तो व्हाटएवर आई हैव theoretical knowledge mostly that I have gained, I will be able to utilize in different domains. ठीक है?
Yes, sir.
तो एक तो अपना बताना कि जो मैंने किया है उसकी एक एप्लीकेशन हो जाएगी, और दूसरी बात यह है कि आप जो है क्या ऑफर कर रहे हो मेरे लिए। ठीक है?
Okay, sir. दोनों चीज एक साथ वो
हाँ,
करते हैं. Okay.
आपने अपना बताना ना कि मैं क्या, मुझे क्या बेनिफिट मिलेगा, उसमें क्या दिख रहा है और मुझ में क्या है, मैं अपनी भी नॉलेज यूटिलाइज कर पाऊंगा वहां पर। बाकी PSUs क्यों नहीं, यही क्यों? तो ठीक है, इवन दो मोरलेस आपने ठीक ही दिया आंसर, इट वाज नॉट वेरी स्पेसिफिक। आप पर आप ये बोल सकते हो कि ठीक है, ओवरऑल सारे PSUs मोरलेस सिमिलर काइंड ऑफ
Similar.
जॉब प्रोफाइल्स हैं। इट इज नॉट लाइक सम PSU इज बेटर देन अदर PSUs। हाँ,
Yes.
जॉब रोल जो है वो हो सकते हैं, मोर स्पेसिफिक हो सकते हैं, बट ओवरऑल रोल जो है वही रहेंगे। ठीक है, सो फिर आपने ऐसे करना है इस केस में कि व्हाट आई थिंक इज इफ आई एम एबल टू, इफ आई join the IOCL, then my journey ends, because whatever I have thought of in a PSU, all those things I am getting in IOCL. So
Okay, sir.
even though right now I don't have calls from other PSUs also, and if I get into IOCL, then my journey ends over there. तो उनको ये बता देना कि ठीक है, मुझे जो चाहिए वो बेसिकली IOCL में मिल रहा है,
मिल रहा है.
so I will not go for any other kind of this. ठीक है?
Okay.
तो एक तो आपको इस लाइन पे बात करनी है, और प्रोजेक्ट के ऊपर आपका पूछ सकता है कि आपने क्या किया है, बहुत ज्यादा, क्योंकि हमने आपको बहुत ज्यादा टाइम नहीं दिया उसको इलेबोरेट करने
Yes,
के
sir.
लिए, पर बी स्पेसिफिक कि आपने ऐसा क्या करना चाहा। मुझे लग रहा है कोविड सिचुएशन में आपने ये इस डायरेक्शन में काम किया,
Yes, sir.
तो स्पेसिफिक क्या, ऐसा तो है नहीं कि गॉट मटेरियलाइज्ड, पर आपने क्या काम किया, क्या चीज है जो कि प्रेजेंटली नहीं थी, और हाउ यू ट्राई टू टैकल इट। कॉस्ट कैन नॉट बी द ओनली क्राइटेरिया। देखो, ये लाइफ सेविंग चीज है, वेंटिलेटर इज अ लाइफ सेविंग थिंग।
नहीं सर, वही था कि जो हमारे पास वेंटिलेटर अवेलेबल इसलिए नहीं थी क्योंकि कॉस्ट हाई थी। अगर हम कॉस्ट उसकी वो कर दें तो ये पर्पस था
हाँ,
सर की,
तो हाँ
तो
ठीक है,
अवेलेबल।
ये रखना, पर आपने ये चीज ध्यान रखनी है कि वो सारे पैरामीटर्स जो है आपके फुलफिल हों।
ठीक है सर।
ठीक है,
वही की
वो
क्वालिटी हमने इतनी नहीं कम करनी है कि कॉस्ट
हाँ,
ही बस ओनली कॉस्ट।
इसमें आपका क्वालिटी इज गोइंग टू बी द क्राइटेरिया।
ओके सर।
कॉस्ट जो आएगा डेफिनेटली आएगा, कॉस्ट आएगा, पर वो सेकंड उस पे आएगा। इट इज नॉट कि कॉस्ट पहले आएगा फिर वो आएगा। तो बेसिक पैरामीटर्स के ऊपर बिना वो विदाउट एनी कॉम्प्रोमाइजिंग, देन हाउ यू आर एबल टू, हाउ यू कुड हैव रिड्यूस्ड द प्राइस। ये क्वेश्चन यही आएगा। क्या बोलोगे? देखो, इनमें ये होता है, व्हाट we tried to do was these were the parameters which were leading to a high cost. तो हमने कैसे ट्राई किया कि वो कम हो? आपने
Yes,
उसका
sir.
प्रोटोटाइप बनाया क्या?
No, sir. Actually, all the calculations and all the
हाँ, तो यहाँ पर फिर
theoretical.
फंसेगा मामला, वो बोलेगा कि
Yes, sir.
जब तक आप उसको करोगे नहीं तब तक जो है वो तो थ्योरेटिकली कंसेप्ट रह गया. When you say theoretically कि I can do this, I can do that, तो वो मिसमैच रहेगा. बट आप ये बोल सकते हो कि we tried our level best to make a model, theoretical model, और आप बोल दो यार डिजाइन किया होगा आपने.
Yes, sir. Designing की थी.
डिजाइन किया बट we could not experiment it. ठीक
Due
है,
to the COVID situation.
कोविड सिचुएशन हमें मौका नहीं मिला, बट अगर मिलता तो शायद we could have done better.
Yes, sir.
ठीक है, तो थोड़ा सा इसमें वो रखना है इस तरीके से. और हॉबीज का थोड़ा सा, जैसे आपने फुटबॉल कहा, स्नूकर कहा, तो उसके आपने केवल मुझे एक ही एग्जांपल दिया.
Yes, sir. वो इंडिया के actually. Yes, sir.
हाँ, तो पूछ सकता है वो आपसे. ठीक है,
Yes, sir.
तो उसको भी वर्कआउट कर लो. ठीक है, तो ये
Yes, sir.
इस तरीके से ठीक है. ओवरऑल अच्छा है आपका, बस थोड़ा थोड़ा ये फाइन ट्यूनिंग करो, इट इज गोइंग टू बी गुड. कोई क्वेरी आपकी तरफ से इस रिगार्ड में?
वो बस इतने थे सर.
ठीक है,
बता दिया
ओके
आपने.
ओके, ठीक है. इसमें फाइन ट्यूनिंग करो थोड़ी सी, एंड आई थिंक व्हेन यू गो फॉर द नेक्स्ट मॉक इट इज गोइंग टू बी गुड.
Okay, sir. Thank you.